This video will cover the beginning of logarithmic functions. We're going to start by graphing an exponential function, one that we're actually familiar with. And so if you remember from last week, remember how we started constructing tables and then graphing them, right? You guys remember that? So for example, 2 to the power 0, who could tell me that is? 1. Very good. So it is a 1. Now what is 2 to the power 1? 2. 2 to the power 2, 4. And 2 to the power 3, 8. Okay, and let's see if you guys remember your negative exponents. So remember, you have the case that you have 2 to the negative 1, that is equivalent to 1 over 2. So I already gave you the answer. So what is 2 to the negative 2?
1 over
1/4 or 1 over 4, very good. And then 2 to the negative third? 1/8, very nice. Now, what I want you guys to do is plot those points here. Let's use one color. You could use your pencil. So remember how we talked about how the y-intercept was the point at 0, 1? And remember, I told you do not touch the x-axis because that x-axis is actually that.
sacred.
Yes, kind of, because the amount will never be 0, right? So it will be, we call it a horizontal, very good, horizontal asymptote. And the equation happens to be x equals 0, all right? So we're going to use all these things in a minute. And this is the graph for the equation 2 to the power x. Very good. Okay, now what I want you guys to do is I want you to just flip or interchange or interchange, that was the best word, the x with the y coordinates, meaning like this. 1/8 goes here, and then -3 goes here. Okay? So just do that for every single row of the table. And what I want you guys to do after that is I want you to plot those points. And so what you're doing right now is you're finding the inverse of the exponential function numerically. By interchanging the x and the y values. That's what you're doing. You're finding an inverse numerically. Okay, so if you finish with your table, go ahead and plot them. And if you notice, instead of having a y-intercept, we are actually going to have an x-intercept for this one, which will be here at y0. We have the point 2, 1. We have the point 4, 2. And we'll have the point 8, 3. Now, I know it's hard to visualize like fractions, right, when you're graphing, but if we want 1/2 of x, it will just be, in between 0 and 1. And the y value is -1, so we'll be right there. The next one's a little tougher, so what I suggest is that you just don't touch in this case, the y-axis. So it's going to look like this. And so that right there, and in fact it does have arrows on both sides. We're going to call this the equation. Are you guys ready for it? Yes. It's going to be log, that's an L, base 2 of x. That is the equation of the inverse function. Okay?
Is it always a cursive L?
Well, the reason I write it like that is because I don't want it to look like a 1, like that. But some people write it uppercase, some people write it kind of like semi-cursive, whatever makes you comfortable in that. You can understand it on your notes. That'll be fine. Okay? Now, instead of having, we already established how this one has an x-intercept, right? So instead of having a horizontal asymptote, what do you guys think it will have?
Vertical.
Exactly. So we're going to have a vertical asymptote right here. So this one has a vertical asymptote at y equals 0. So you guys remember how we exchanged x and y, right, from this table to the other? So same things are happening graphically here between each set of points. So for example, the point that used to be 0, 1, now you can see it here at 1, 0, right? Because of the change that we did numerically. So you can see it graphically here. Now, inverse function, I can tell you with 100% certainty that these two functions are inverses of each other, okay? So inverse functions, when you graph them together, you could see that they are reflected across something. Do you guys remember what that something is?
Axis.
It's not the x-axis, not the y-axis.
Identity function.
The identity function, yes. So the identity function is the one with the equation y equals x. So all inverse functions reflect across that line, because what do we do numerically right here between the x and y coordinates? We exchange them, right, to find the inverse, so that it makes sense that they reflect across the identity function, which is called identity because the input is the same as the output. All right, so let's move on to the next slide. Well, any question here with the two graphs? No, not yet? Okay, awesome. Of course, the domain and the range will change from exponential to logarithmic, but we'll talk about that in a minute. Okay, so right here, we already found how to find the inverse numerically right here, graphically right here. So now we're going to do it algebraically. So back from last semester, we did very few problems. We didn't do a lot. But I don't know if you remember the rules to find the inverse of a function. And I used to number them for you. So the first one is to replace, oops, sorry, let me write as function notation. 2 to the power x. So the first is replace f of x with a y. So f of x gets replaced with y. And then step 2, you interchange x and y. So the y becomes x, and the x becomes y. Yeah, it kind of sounds familiar. So we're going to keep using this. Before the Christmas break. And then third is solve for y. Now, how can we solve for y? Isolating, yes, that's what we need to do. But if you guys have to like just take a wild guess, what would you tell me? Square root. If we take the square root, we'll end up with square root of x and then square root of 2 to the y. So it wouldn't work. Any other idea? The y root, of course. I always hear that one. So we take the y root here, and then we take the y root here. So yeah, it will cancel there, but then I have it here.
Now you no longer have a y.
Yeah, I do. It's right here.
Oh.
All right. So
Miss, you could solve it by erasing the y.
that's true, but that wouldn't be mathematically correct. So the only way we could do here is take a log. When I say take a log, I just me being lazy and not saying take the logarithmic function of 2, okay, base 2. So that is what we do. Doing it kind of like what you do on the left, you must do on the right. It will look like this. Like that, all right? Now, there is one property that we're going to cover in a minute. Let me show it to you. Where? Oh, the exponent was a y, I'm sorry. Yeah, that's good to know. Okay, there's a rule. Let me show it to you. Yes. Oh, thanks for reminding me. I'll pick him up after the break. There's a rule right here. Do you guys see it? Go where? Are you serious?
Yeah.
Okay, let me just finish this. Don't pack. Don't pack. Yeah. I think I have a minute. Okay, just bear with me. Do you guys see this rule here?
Yes.
You can cross that out, and the answer is that. So that is exactly how you have to solve for that. So you just end up with this, which is 1. And so we'll continue on that next class. All right, guys? Sorry I didn't give you a break. I really lost track of time. Oh, no, I did give us a break.